In this section, we're going to talk about something called rate of change. Let's say John takes a road trip, and the graph here describes his journey. We want to find John's rate of change at each position. Now, any slope that describes a real quantity is called a rate of change. The slope tells us how one quantity, y, changes for every unit change in another quantity, x. This example is actually a familiar rate of change known as miles per hour. The rate of change of any distance to time graph like this actually describes a velocity, which is actually a really important concept, especially when you get into higher mathematics and calculus and whatnot, when you're talking about taking the derivative of something, which is just a fancy name for slope. But that's neither here nor there, so let's go ahead and find the rate of change at each position. So let's start with A. Our rate of change is basically the slope here, and we're defining an actual real quantity, talking about speed. So we're finding the slope in actuality. So we want to find the change in y divided by the change in x. So let's start. We start at 0, and we end up with 80. So we have 80 miles that we've driven in 1 hour. So we start with a time of 0, and we get 1 hour. So this is such. 0 minus 80 is the change in y, and 0 minus 1 is the change in x. So we have minus 80 divided by minus 1. We can cancel the negative signs, and this will give us 80 over 1, or just 80. So John is actually traveling 80 miles per hour for this little black section right here. He goes 80 miles in 1 hour, which is seems very simple to think about, but we want to prove the mathematics behind it by finding the slope in terms of rate of change. Okay, so let's move on. Next, we're going to find this blue section here. So at B, we're at 155. So we're at 155. We're going to use this point as point 2, or as point 1, and this point is point 2. It doesn't matter which one. I just like to keep things positive. It makes things a lot simpler. So 155 minus 80, which is where we started in this little blue strip. 55 minus 80, and then 2 minus 1. So we have 2 minus 1. That'll give us 75 over 1, which means for the blue section, he traveled 75 miles per hour. Okay, let's find out about the green section. This seems pretty intuitive, but let's go ahead and do the math. We have 155 minus 155, so we didn't go anywhere, but we spent an hour, so 3 minus 2. So maybe he was just sitting somewhere, taking a break, grabbing some coffee. 3 minus 2 is 1, so he went 0 miles per hour. He went nowhere in 1 hour. Okay, let's find this pink, the red section, D. We have 210 minus 155, it's the change in y, divided by the change in x, 4 minus 3. And this will give us 55 divided by 1, or 55 miles per hour. Okay, let's find this pink section, E. Again, we have 210 minus 210, which is going to give us 0. We have 5 minus 4 in the denominator, so that's going to give us 0 over 1. So maybe he took another break. So we have 0 miles per hour. We didn't go anywhere in 1 hour. And for F, this blue section here, purple section, we have 300 minus 210, which is the difference in the y coordinates. Difference in x coordinates here is 7 minus 5. So we have 90 divided by 2, which simplifies to 45 over 1. 45 over 1, or just 45 miles per hour. So he traveled 45 miles per hour, but a length of 2 hours, so he traveled 90 miles. Okay, so this is an example of a rate of change, also known as velocity. We can think of it in terms of speed as such and such miles per hour, but whenever we have a slope that describes a real quantity, we can think of it as rate of change. This is actually extremely important, so we'll do another example in the next video. But go over this one again just to make sure you get the idea of the slope behind the rate of change. I'll see you soon.